So what two things describe any type of arithmetic growth? Well, if I know where the arithmetic sequence starts, so starting point, and the progression, which is a common difference, or common difference, if I know those two things, I can describe any arithmetic pattern growth. Well, these two things show up in linear relationships, and they relate to the starting point is the y-intercept, and the progression is the slope. So these things go together, and it's important to connect these two because really they are the same thing when we talk about arithmetic growth. Okay, arithmetic growth is a linear pattern. So here Kai runs for a school track team, and his training involves increasing the number of laps by a constant amount. So first week he runs 3 laps, the second week he runs 5 laps, the third week he runs 7 laps. So we want to find the number of laps he ran in week 9 and the total number at that point. So let's figure out week 9 first. So the n is equal to 9, we start at 3, and we're going up by plus 2. So week 9 is T9, 3 plus the number of steps we did is 9 minus 1, or 8 steps, of plus 2. On the 9th week, he ran 19 laps. Okay, so there's the total number of laps run to that point is going to be S9. S9 is going to be the number of laps, the number of weeks divided by 2, or this is pairing up each term, and it's going to be the pairs of the first term plus the last term. So pairs of 22 will give us the total number if we add them all together. So 22 times 4.5 gives us 99 laps in total. This last part of this is, what would the total number of laps be if he started with 3 laps and increased it by 50% each week for 9 weeks? Well, this is a geometric sequence. So it's going to be 3 plus multiply by 150 to get 4.5 plus dot 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 dot. And really this is going to be S9 for a geometric series. For a geometric series we need A, R, and N. Well, we know A is 3. We know the R is going to be increasing by 1.5. The number of weeks is 9. So it's going to look like this. So putting this all into our calculator, the number of laps he's going to run is going to be 3 times 1.5 to the power 9 minus 1. That's all divided by 1.5 minus 1. And he ends up running 224.66 laps by doing this. And although at first he's not gaining very much each week, because it's geometric, this grows quickly, very fast. So this is why the total laps here is more than the total laps when we did arithmetic growth.